the writing of chemical equilibrium expressions, and this is basically to see, do you know how to write down the formula and can you substitute correctly? Now the reality is this is fairly trivial. It is, practically obvious, but we are going to do a few examples just to make sure you all are 100% clear on them. Okay, now the first thing I want to do before I continue is I just want to talk about formulae that you find in your book. Remember, we gave you a formula for this reaction. AA plus little bb gives me little cc plus little dd. Okay, and then the equilibrium constant for that specific reaction was Kc is equal to concentration of C raised to the power of little c, concentration of D raised to the power of little d, divided by concentration of A raised to the power of little a, multiplied by concentration of B raised to the power of little b. Okay, now you may find that some textbooks will write this as that Kc is equal to the concentration of products divided by the concentration of reactants. Now I'm going to tell you that this is not the case, and please do not do this, because we have given you the formula for Kc for this specific reaction. This, if you write this down first in an examination at grade 12 level, it will be marked incorrectly because it is not the formula for Kc. It is just an easy way to remember that products, the right hand side goes on top, and reactants, the left hand side goes at the bottom. But please, this is not the formula. Okay, so I'm just going to clear that, and then we're going to go into the exercise and do some of those examples. Okay, now these ones are fairly trivial. We will come to exceptions where we don't include the concentration of certain reactants in the reactants or products in the actual formula. But all of these ones, they must go into the formula. And the reason for that is we always include gases and we also include aqueous solutions, right? There's something that will be left out, which we'll discuss later on. Okay, so let's do the equilibrium constant for A. That says Kc is equal to the concentration of whatever's on the product side, and in this case it's the O2 gas raised to the power of 3 divided by the concentration of the O3 gas raised to the power of 2. That's your solution for A. Let's do B. Well, again, we have to put all the products, the right hand side stuff on top. So I'm going to write down Kc is equal to the concentration of this thing over here, which is NaCl, raised to the power of 2 divided by nitrogen monoxide, its concentration at equilibrium, remember at equilibrium, raised to the power of 2 multiplied by chlorine gas raised to the power of 1. Okay, but I don't need to write in the power of 1 because it's trivial. Okay, and then let's do C quickly. Again, we write down Kc, and that's equal to the concentration of this ion at equilibrium, which is going to be silver nitrate, NH32, and that's a plus ion raised to the power of 1 because the balancing number over here is 1, as you can see if there's nothing there. Same with the chlorine gas, divided by our reactants over here is the silver ion, which is Ag plus, raised to the power of 1 because there's a 1 there if you don't see it, and in this case it's balanced already. If these reactions are not balanced, you will have to balance them, but in most cases in the matric examination you're given a balanced equation. Okay, and that's going to be ammonia, NH3, the concentration of ammonia. I don't know what's happening with the angles over here, my head must be skewing, and that's raised to the power of 2. So there you go, there's a few examples of how to write out the formula for given reactions of the equilibrium constant. Remember, it's always going to be dependent on this. So if you get a mark for physical sciences formulae, you write down this formula. You don't write down concentration of products divided by concentration of reactants, as I previously showed you. That is not the way to do it. Okay, that's that, and this is this over here.